All right, let's dive into one of the absolute cornerstones of all reinforcement learning. It's the fundamental building block for teaching an AI how to learn all on its own through pure interaction. It's called the agent environment interface, and we're going to break down exactly how it works.
So, have you ever wondered about this? I mean, really thought about it. If you can't just hand an AI a rule book for how to beat a video game or, I don't know, how to fly a drone, how on earth does it figure it out? How does it learn just by doing stuff? Well, that's the exact problem this whole interface is designed to solve.
Here's our game plan for the next few minutes. We'll start with why this whole framework is so critical. Then, to make it all click, we're going to use a super simple analogy: training a dog. After that, we'll break down the official components, see how they all work together in a powerful learning loop, and wrap up with the one key idea that makes it all possible.
Okay, so first things first. Why do we even need a special interface? Well, think about it. If you're going to teach something through trial and error, you need a standardized way to communicate, right? The learner has to have a way to see the world, a way to try something, and a way to understand if what it did was good or bad. This interface is that common language.
And this isn't just some big concept. It's a formal way of framing the problem, which is what makes it so powerful. You've got two key parts here: a goal-seeking agent that's trying to achieve something, and an uncertain environment where it doesn't know the rules ahead of time. This simple but brilliant setup is the foundation for pretty much everything else in reinforcement learning. Now, I know formal frameworks can sound a little academic, so let's bring this right down to earth. Probably the best way to get an intuitive feel for the agent-environment interface is to think about something we can all picture: training a dog. You'll see, it's an almost perfect one-to-one match. So let's lay out the pieces of our analogy. First, you've got the learner, the one who's trying to figure it all out. That's the dog, obviously. Then you have the world it's interacting with. That's everything else. It's you, the trainer. It's the room you're in, the commands you're giving. And finally, the goal. For the dog, the goal is super clear and very immediate: get that treat.
Okay, now that we have our dog analogy really clear in our heads, let's start mapping it to the official terms you're going to hear all the time in reinforcement learning. We're going to go through each piece of the interface one by one and tie it right back to our little dog training session.
First up, we have the agent. The agent is the star of the show. It's the learner, the decision maker. In an AI context, this is the algorithm that's doing the learning. But in our analogy, it's the dog. Simple as that. It's the one looking around, thinking, and choosing what to do next.
So the agent has to exist somewhere, right? It lives inside the environment. And the environment is, well, it's literally everything that is not the agent. For our dog, the environment isn't just the physical room. It's also the trainer, the words you say, the tone of your voice, the whole setup of the problem it's trying to solve.
But how does the agent know what's going on in its world? It gets information about the state. You can think of the state as just a snapshot of the environment at one specific moment in time. For the dog, the state is everything it's sensing right now. It sees your hand signal, it hears you say sit, it feels the carpet under its feet. That's the state.
Okay, so the agent sees the state. Now what? It has to do something. It takes an action. An action is any choice the agent can make that might change the environment. So after hearing sit, our dog has a bunch of actions it could take. It could sit, sure, but it could also just lie down or bark or just totally ignore you and wag its tail.
And here it is, maybe the most crucial piece of the whole puzzle: feedback. After the agent takes an action, the environment gives it a reward. Now, this is just a number, a score. A positive number says, "Good job, do more of that." A negative number, or 0, says, "Nope, that wasn't it." Getting a treat is like a big +1 reward. Hearing "no, bad dog" is a negative reward. This simple score is the only thing guiding the agent. So we've got our main characters, the agent and the environment. And we've got the messages they pass back and forth: state, action, and reward. But these things don't exist in isolation. They're locked in this constant back and forth, a cycle that we call the learning loop. Let's walk through how it actually plays out. This right here is the rhythm of learning. At every single tick of the clock, this loop repeats. Step 1, the environment sends a state. So you, the trainer, give the sit command. Step 2, the agent sees that state and chooses an action. The dog decides to sit down. Step 3, the environment sends back a reward. You give the dog a treat, a nice +1. And finally, step 4, the environment sends a brand new state. The dog is now sitting, waiting for what's next.
This loop just goes on, over and over, thousands, maybe millions of times. And every single time, the agent gets just a tiny bit smarter.
So what's the one big idea that makes this whole thing work? I mean, what's the actual principle that gives the agent its motivation, its purpose? It all comes down to one really powerful idea. This is known as the reward hypothesis, and it is the philosophical core of this entire field. It's a huge claim. It says that any goal you can think of, whether it's winning a game of Go, or landing a rocket on a barge, or discovering a new drug, can be framed as one simple thing. Get the highest possible total reward score over time. That's it. The agent's entire existence is dedicated to making that number go up. And that's really the beauty of it all. This elegant, simple loop, state, action, reward, it's like a universal translator for learning. It doesn't care if the agent is a program learning to play an old Atari game by looking at pixels on a screen, or if it's a physical robot learning how to walk. The fundamental back and forth, the process of interaction and feedback is exactly the same. So I want to leave you with this final thought to chew on. If it's true that any goal can be achieved just by maximizing some numerical reward, that totally changes the game, right? The challenge isn't about programming a step-by-step solution anymore. The real challenge becomes designing the perfect reward signal. So what amazing, complex, or creative goal would you want to teach an AI if all you had to do was figure out the right way to reward it?